Oh, come on.
Okay. It looks like we have everybody. I'm not sure why, Mr. Markman, but we have you twice. Are you audio and video through separate connections? You're on mute on both connections, though.
That's me. Let me see what let me try.
Okay.
Something.
Okay, while you're doing that, we'll go ahead and get started. Good morning, everybody. My name is Alan Lilly. I'm the presiding hearing officer of the State Water Resources Control Board's Administrative Hearings Office. Today is November 1st, 2022. It's just after 9 a.m. This is the fifth day of hearing in the Administrative Hearings Office proceeding on the reference from the court to the State Water Board in City of Marina versus RMC Lonestar. I don't think we need appearances. It appears that it's all the same attorneys that we have had for the last several days. So unless there are any other preliminary matters, we'll just go ahead and get started. We have received various uploads of exhibits from CalAm, which we've moved over to the CalAm exhibit folder, and we will address those at the appropriate time. But I think now let's just go ahead and continue. Mr. Osias was conducting his cross-examination of Dr. Ash. Dr. Ash, just a reminder, you still are under oath. And Mr. Osias, you may proceed.
Thank you, Mr. Lee. I saw Mr. Wilkins' hand up. I didn't want to.
Oh, I'm sorry. I've got so many tiles. Mr. Wilkins, was your hand up?
It was, but I just wanted to let you know that Dr. Ash completed his homework and sent me a geophysical publication that you requested yesterday, and I will have that uploaded, Bates numbered and uploaded with a revised exhibit list later today.
Okay, and can we just number that as the next Marina Coast exhibit?
That's the reason I will figure that out and do that, yes.
Okay, let me just check. I think I'll see what numbers we have, and you can tell me if you agree. Thank you for letting me know about that.
Okay.
Just a minute here. I'm going to, takes me a few clicks to get there. So Mr. Wilkins, okay, I have through MCWD 105. Oh, but there must be a couple of others because I believe we were going to mark Dr. Ash's slides as MCWD 108. Is that correct?
That's correct. And I believe there's two deposition transcripts that are 106 and 107. And as I think my secretary had the nerve to go to Scotland for 2 weeks. So I'm a little shorthanded administratively, but I will get caught up and get that submitted today with a revised exhibit list.
Okay, so we will have the technical article from Dr. Ash be exhibit MCWD 109.
I believe that's true, yes.
Okay, thank you. And with that, let me just move this over here. Okay, so with that, you may go ahead and Mr. Osias, you may proceed.
Thank you. And I'd like to go back to MCWD Exhibit 4, page 29. That's PDF page 29.
Okay, we will post exhibit MCWD 4. It may take us just a minute. We have to download it again. And I'm sorry, what page number?
29.
Okay, and we will go to page 29. And you may proceed.
And if we can scroll down, it's this table or figure, I guess, to use the correct word, that I had a question about.
Okay.
And let me adjust my view so I can see everybody. Thank you. Good morning, Dr. Ash.
And just a reminder, verbal answers, please.
Do you see on the resistivity scale the number 40?
Yes.
And the bar immediately to the left of number 40 is all tan colored, correct?
Except for the very top, maybe another color there that it's hard to tell what it is.
Thank you. I didn't actually see that from my printed version. So there's some other color and the rest is tan. I'm sorry, correct?
Correct.
And what ohms does that column reflect?
And just so we're clear, Mr. Osias, it's ohm meters.
Oh, thank you. Yes, I did mean that, and I apologize. Ohm meters.
It is probably about 37 to 39 ohm meters.
Thank you. And you see the number 30 on that horizontal axis representing ohm meters, correct?
Yes.
And 2 bars to the left of that number is a bar that is mostly purple with some light blue on top. Did you see that?
The second bar to the left of 30, yes, I see that.
Okay. And roughly what, or approximately what ohm meters does that bar reflect?
That is probably about 25 to 26 ohm meters.
Okay, thank you. Did you provide a table that identified each of the 2,000 measurements contained within this table and identifying the corresponding TDS and which monitoring well and that corresponded to each of those measured resistivities?
No, there is no such table that I am aware of. There probably is a table with Stanford, but I have no knowledge of it.
Thank you. Could we turn to page 30?
Okay, we'll go to page 30.
And going to line 16. One word in on line 16, a sentence starts with the word there, when it talks about, quote, there are very few resistivity values in figure 12 where the resistivity measurements correspond to TDS concentrations less than or equal to 1000 mgl, comma, without overlap from another TDS range, period. You see that sentence?
Yes.
And that's your testimony, correct?
Yes.
And then the next sentence reads, the range of resistivity values is approximately between 55 and 75 ohm meters, period. You see that?
Yes.
That's your testimony, correct?
Correct.
And then the last sentence, because of the low percentage of AEM resistivity measurements corresponding to this range, comma, we focus primarily on sources of drinking water in this report rather than on drinking water, period. That's your testimony also, correct?
Yes.
And in that last sentence, this range refers to 55 to 75?
No, I don't believe, no, I don't believe that's the case. I believe it's the 20 to 75 range. They're just pointing out in that line 18 that where you see the less than 1000 only is between 55 and 75. And one of the issues with the well data in the whole survey area is that there are not a lot of water sampling reports where there are low TDS values. And that's what they're pointing out here. And I also pointed out in the 2019 report.
Okay, so I have a couple of questions about your answer. I'm sorry, I thought it was a short, was going to be a short answer. You use the pronoun they. Who is the they?
Please clarify. I don't recall.
You said in response to my question, they are reporting on, and I didn't know who the they is.
They would be someone who, I'm not sure which day you're talking about. Again, the first line 18 refers to where there's less than 1,000 is a range of 55 to 75. And because of the low percentage of AEM resistivity measurements corresponding to this range, they're going to focus on sources of drinking water. And it says we focus, and this is Ian Gottschalk and Rosemary Knight at Stanford saying this.
Oh, I see. Okay. So that's who the we is in line 19.
Yes.
And now I think you just said that the words of this range do refer to the 55 to 75 ohm meters from the sentence before. Is that correct?
Yeah, I believe so.
Thank you. Thank you.
I'm guessing. I'm not positive, but I'm guessing that's the case.
And you're guessing because this is actually comes from Mr. Gottschalk and Dr. Knight.
Yes.
Thank you. On page 16, can we go there, please? And let's go down to the lines 26 and a half. I apologize for the half, but they're sort of not quite in alignment. And I'm starting with the sentence resistivity values at the bottom of the page there. Do you see that, Dr. Ash?
Yes.
And because the next page has only a partial sentence, why don't you just read this bottom of this page, starting with resistivity, and let me know when you're done.
Resistivity values.
No, you can just read it to yourself. Sorry.
Okay, it's okay. Okay. Scroll down, please. Okay. How far do you want me to read?
No, that's fine. I just wanted to make sure that I'm going to ask you questions starting with the sentence in, and I wanted to make sure you knew how the paragraph started on the page before. Okay.
Okay.
So the sentence starting with in says, in every display of the data, we show resistivity values above the depth of investigation, paren DOI, close paren. That's your testimony, correct?
Yes. Yes.
Well, did you want to explain? Is there a but?
DOI is a whole separate conversation. So go ahead with your questions, please.
And the we in the line one is Mr. Gottschalk and Dr. Knight?
Yes.
And then the next sentence says, below the DOI, the resistivity values are poorly resolved, period. Did you see that?
Yes.
And that's a true statement, correct?
Yes.
And for someone who's not an AEM guru, is poorly resolved like with a camera where at some level you can't focus because you're either too close or the camera is unable to create a clear image? Is that what resolved means in a rough sense in that sentence?
Approximately. At every sounding, based on the resistivity, there will be a depth of investigation at which the resistivities above the depth investigation are very well resolved. But below the depth investigation, the resolution begins to decrease with depth.
Okay.
So it could be equivalent to your out of focus sort of thing.
Oh, thank you. I was just want to make sure I didn't misunderstand what resolved meant. And it's sort of, it's a parallel, not exact to focus in the camera is what I was asking.
Yeah, yes.
Okay. And then I think you just said what the next sentence says, which is the DOI depends on the resistivity structure of the subsurface. Is that correct?
That's correct.
And then, and that's your testimony, correct?
Yes.
And then the next sentence, if the resistivity of the subsurface is, comma, on average, comma, low, comma, the DOI occurs at a shallower depth than if the resistivity is high. So the DOI decreases with depth. Is that fair?
Not quite. As it says, if the resistivity is on average low, the DOI occurs at a shallower depth than if the resistivity is high. So I'm not sure your decrease, I could take it two different ways.
Okay, I apologize for the ambiguous question. Let's go just to the next sentence. It says, while the DOI varies significantly across the region of interest, it is approximately 50 mbgs in saline. Let me just stop there for a minute. mbgs, is that meters below ground surface?
Yes, correct.
Okay. And that's saying that the DOI for saline water is approximately 50 mbgs, correct?
It's approximately, there's going to be a range based on the degree of TDS salinity and the geology. But
and then the sentence goes on to say that less resistive regions along the coast and between 150 and 200 meters below ground surface. That's what the rest of that sentence means, correct?
correct.
Okay. And then if we can turn to page 18. Well, let's just stay with the top for a minute because we defined the figure below. You mapped the DOI in part, along with other features, in figure 3 below. Is that correct?
It's plotted, and it's a DOI is plotted. What that DOI is, I don't know, but because I didn't make the plot.
Okay, so but your test.
May I explain?
Please.
The DOI, as I was saying earlier, is dependent on the subsurface and on the resistivity of the subsurface, and that I've done quite a bit of research on the DOI, and that the programs that we normally use for these inversions call them standardized values for calculating the DOI. It may not be the DOI specific to that place, the location, but it is an estimation, approximation of a depth of investigation. In the programs we use, there are two values that are used. One is called conservative and one is called standard DOI. I don't know which value is plotted here. And if it is the standard DOI that is plotted, or the conservative, or some other DOI, because I didn't make the plots, so I'm not sure. But it is representing a DOI. What that DOI is and where it came from, I can't say.
Do you see line 5?
Say that again.
Line 5?
Line 5, yes.
Okay, and it says, the region shaded in gray signifies the region below the DOI. That's your testimony, correct?
That's correct.
Okay. Can we scroll down now so we can see figure 3? we might need to reduce it one click.
Okay, we'll reduce it one so we can get one click. There we go. So there we can see it all.
All right, so just to orient us, Dr. Ash, to the symbology or whatever it's called in this figure, in the boxes to the right are what I would call a plan view map with an A prime to A red line, or a B to B prime, or a C to C prime. Do you see that?
Yes, location maps.
Okay, and that is trying to identify the cross section that's to the left of each of those, correct?
Correct.
Okay, and although the symbol prime, I guess, or apostrophe for the B and C are missing, I assume they're also on the right, just like A prime, correct?
Yes.
Okay, and this figure 3 was also in your summary slides, correct?
Correct.
Okay, so this is part and parcel of your testimony. And in the description below figure 3, in the last phrase of the last line, it repeats that regions below the depth of investigation are shaded in gray. Do you see that?
Yes.
And so each of these plots, I guess is the correct word, has a gray section. Do you see that?
Yes, to a degree.
And if we look at the B cross section, the portion of that plotted cross section closest to the line numbers is the west.
Is that a question or a statement?
That's a question. I just want to make sure we're oriented right. That the vertical scale, let's say on the plot, the vertical scale is the western portion of that plot.
The vertical scale of depth is the western portion of that plot.
Thank you.
For B and for C. For A, it's north.
Okay, thank you. And at the coast then, the depth of the DOI is 50 meters, correct?
At that location, yes. On B.
Okay, and on C, at the coast, the DOI depth is 50 meters, correct?
Yes, for that location.
Okay, and because it's may not be obvious, the horizontal scale for each of these plots is not the same, correct?
Correct.
C extends out past 12 kilometers, while A and B only extend out 8 kilometers, correct?
Maybe more like about 9, but yeah, that's.
Oh, okay. Thank you for that correction. Do you recall that on some of the thickness maps where we were plotting the thickness of different TDS qualities, the scale went from 2 to 80 meters?
Yes.
And there were some deep colored sections near the coast that looked like they were, 50 to 80 meters, correct?
So, excuse me, we're getting an echo. If there's somebody besides Dr. Ash, Mr. Osias, and me who has their microphone on, please turn it to mute. I think that'll help the echo. And of course, you can unmute if Mr. Wilkins if you want to make any objections. But with that will help us a lot. And I'm sorry for interrupting, Mr. Osias, but please ask your question again.
Actually, I'll withdraw that and rest. I promised you only 10 minutes, and I hope I delivered.
Okay. All right. Well, I didn't mean to cut you off. You can ask the last question if you want.
I think it would just be going over ground we covered, and there's no reason.
Okay. It's just the echo was bothering me. That was all. Okay. Well, thank you, Mr. Osias. And Dr. Ash, I have some questions, not necessarily in logical order, but just the way I wrote them down. So we'll just go with them. Ms. Mullen, if you can please put up the slides, exhibit MCWD 108. And just go to slide 2. Okay, Dr. Ashton, these are just background questions that will help me understand this. The current that this figure shows the current going around the loop, which I call the primary loop. I mean, your slide here states that a primary magnetic field is generated. Do you see that?
Yes.
And is the current in the primary loop alternating current or direct current?
Alternating current.
And what can you tell me approximately how many amps that is?
This is a SkyTem system. For the SkyTem system, it's called a dual moment system. And a dual moment system, what that means is that there are two call it series of amps of waveforms that are transmitted around the loop. There's a low moment current, which is about 8.7 amps. And then there's a high moment current, which means high amperage, which is about 100, and depends on the system and variation, but maybe about 115 to 120 amps. And
Okay.
It's kind of going in a bit of a square wave.
Oh, that was going to be my next question. Are they both square waves?
Yes, they're both square waves of different. I work in frequency online, a different time.
Okay. Well, so and then what are the approximate? So AC is perhaps a little bit of a misnomer. It's not your typical sinusoidal wave, but
it's not a straight. It's not a straight 60 hertz wave. No. Basically,
so what are the approximate? I'm sorry. Go ahead.
Let me explain how time. Let me start with. In electromagnetics, you could work in what we call frequency domain, which works with like your 60 hertz signal going like that, or 30 hertz or 120 hertz, whatever, and it's a continuous waveform at that frequency. Now, the alternative of that, it's reciprocal actually, is we call the time domain. In the time domain, what happens is you ramp up your current and it becomes stable to, say it's 100 amps, whatever, and then you turn it off. You turn off the current, okay? Now, I don't know if you remember, if you turn off your light at home, the light doesn't turn off exactly on that instant. It kind of slowly turns off, all right? And so the idea in the time domain exploration is that you have ramped up your current, it's stabilized, and then you turn it off. So what happens is during that turn off, we are measuring, how it turns off, how that current turns off until it goes to 0 amps, okay? So now it's turned off. It took a little bit of time, and that could take, we're talking microseconds here, okay? But it takes a little bit of time to turn off. And then at a certain time after it has turned off, we start measuring the received magnetic field, okay? And that, depending on what system you're using, and there's all kinds of variations of that. For the early time SkyTem system, like the 304 that was used in the 2017 data, that first time that is usable is about 8 to 10 microseconds after the 0 amperage point. Okay. Now that is for the low moment. Okay. Now the high moment, because it is now at 100 amperes and it's stabilized and it turns off, it takes much longer to turn off. And for the high moment, it turns off. It takes about, if I remember correctly, depending on the system, but it takes about 57 to about 65 microseconds to turn off. And so the first high moment measurement in the time domain is at about 70.5, 72 microseconds. Okay, so that's the idea of how time domain works versus frequency domain.
Okay, so then what is the rough frequency of the square waves then?
I don't know. I can't remember exactly. They're like about 1,000 hertz, I think.
Okay.
I think the
And then
pole,
just to get an idea, so there's the secondary magnetic field is detected in those receiver coils. So what types of currents and amps is the secondary coil picking up?
so remember the secondary coil, the coils are measuring. So the primary field goes into the ground, the current flows, it induces eddy currents, you get a magnetic field coming back up. So what is measured is not in current, but it is in magnetic field, dB dt, the change in magnetic field with time. So it's basically a magnetic field. It's a gradient or time variation in magnetic field is what is measured in the receiver coils. They're not measuring direct amperage. They're
Okay,
measuring
I just
magnetic
thought
field.
there must be, I thought there'd be a conversion. I mean, there obviously is current flowing in those secondary coils, but maybe you don't know the answer of what the current is.
No, we usually don't even look at that. We usually look at the amplitude of the magnetic field in those coils, dB dt.
Okay. Okay, that's helpful. Thank you.
I can tell you
So-
that on the front side, that when we're looking at it's extremely important as part of the setup of the system and quality control that they measure the transmitter waveform extremely carefully, beginning, during, and after the survey, to make sure we know exactly what went into the ground for both the low moment and the high moment. Okay. On the back end, on the receiving coil, the importance there is that it's where it's positioned. Now, if you look at the figure here, and you remember that the black loop is kind of the transmitter coil. On the front end, you kind of see a point, like a linear point there. That's where the magnetometers go and altimeters and things like that. They go on the side. But at the back end, you see kind of a vertical rectangle sticking up. And that is the location of the receiver coils, okay? Now, part of the process of setting up the system and checking that it's working is positioning that receiver coil in exactly the position that has the least influence from the transmitter coil. And they call that the null position. Okay.
Oh, I was wondering, even though during the time when the receiver coil is measuring it, the transmitter coil is turned off, you still have to avoid the influence?
There is still, basically, you've got a big metal loop there, a big piece of metal wire, which will pick up its own natural, its own natural receiver of magnetic field. And so it can transmit it back anywhere, just it starts expanding it back out. And so then the receiver coil will see that. So we try to position it so it's reduced as much as possible. So we have the least amount of influence from the transmitter coil and the rest of the electronics anywhere else on the system. That's why they're the furthest away on the other end.
So is that why in this figure, it looks like both coils are in the same plane, basically?
Yeah, typically and always, really, what happens, different systems, you'll have, say you see here, a horizontal transmitter coil. In some other systems, the receiver coil is kind of maybe 5 meters above it, but also horizontal. And so what happens in the end is they have to co-locate those coils to the same position, same elevation. And that's just part of the process of dealing with the data. For the SkyTem systems, they originally, like about 15, 20 years ago, they may have started with that coil in the middle, but they found that they can get better data by positioning it at the back end in what they call the null position, so they can get much higher quality data at earlier times, which gives them much higher resolution in the near surface.
Okay, that's helpful. Thank you. So if we can move over to slide 4, please. Now, you testified about this slide before, Dr. Ash, and I just want to make sure I understand this. There's a dark blue, I'll say, curve and a light blue curve. Can you tell us what those depict?
According to the figure legend, the light blue refers to what they're calling anomalously low TDS in the dune sand aquifer. And the dark blue is anomalously low TDS in the 180-foot aquifer.
Okay, and do you know what anomalously low means? Can you put a number on that?
I have no idea what that means, what the range is. they never mention it in the report or anything. I don't know if that came from the Monterey, County Water Agency. I don't know what it means.
So you don't know the source?
No, I don't know the source, and I don't know how low is anomalously low.
Okay. Okay, let me keep going here. We can go to slide 13, please. Now, Dr. Ash, you did testify about this table on the left, and this is civilian trying to understand detailed technical information, but I could not figure out, there are totals at the top. There's a row called totals at the top, near the top of the table on the left. And then there's another row, the very last row says total of aquifers. So and the totals numbers are all higher than the total of aquifers numbers. So what is included in the totals that's not included in the total of aquifers?
I wonder if it is on the right. They're including the values on the right, but I'm not sure. Because they got total aquifers is 17.64, say for the limited beneficial use, let's pick that one. And if you add in, because if you add in then these other ones, it'd be much higher than that. So I don't know exactly what they're basing that on. I understand the total. What we could do right now is add those guys up from the perch A to the figure 25 values. We could add it up right now and see what they add up to, and then see what happens if you had to add in something from the other table, other side.
Okay. Okay. Well, we can do the math on our own. It's a mystery to me, but it sounds like at least now it's a mystery to you.
A very good question. Let's see here, 30.
Go ahead.
No, I'm just thinking out loud, looking at the two tables. No, that's a good question. I think in mine I did check those values and I did add them up and make sure they all added up right. Sure
what do you mean by yours versus this one?
In the 2019 report. This is from the 2017
okay.
report.
This is 2017. Is that in your testimony? I don't see that in the slides here, but is that in your testimony?
It's not. It's in the report. I figured, like, because you see all these numbers and you just gloss over, so I decided not to put it in.
Okay. All right. Thank you. That's the clarification. Let's move on here. Okay, so we'll go to slide 21. And my staff asked me to ask you, and I think you said this, but you may have gone a little fast for us. You said that you took out 6 data points from this table 4-5 in slide 21. Is that correct?
So what I would say is, you have to flip back and forth. But now I think go down to slide probably 23. It should be the same table with some extra columns, and one of those columns is the cut points.
Okay, got it. Let's go to slide 23. That is helpful.
It's gonna be the same data as in here, but a few extra columns of information.
Okay, so here, and that shows there's an out or cut column there. Go ahead.
That's supposed to be cut, yes. And so you see there's 6 red X's that were cut from the EC regression calculation and 2 blue X's from the what they call the actual connectivity regression calculation.
And so we'll take them one at a time. Please explain why you cut the 6 data points from the EC regression calculation?
Now, typically, the source, it's a little more difficult to see it on here in the table, but we can. Typically, we do the regression calculation. So let's go up one slide.
Okay, we can go up to slide 22.
Okay, so now on the left is the regression between the airborne resistivity and the water resistivity based on the actual conductivity. And so what happens is you see the black line, that's the trend line, and you see these orange boxes along the trend line. Those are all along the trend line, what they call predicted LN rho AC. Okay, now but you didn't see these blue dots. So the blue dots are it's kind of the plotted point where you have some value of rho AEM and some value of LN rho W AC. And what happens is the points that are furthest away from the line have a great level of distortion on the line. Now this is the AC data, so there were only 2 points that were actually cut. I don't remember which 2 they were. Okay, so basically the points that are furthest from the trend line are usually going to be investigated first. So I would identify the points furthest away, and then I go back to that table. Let's go down one slide to 23 again.
Okay. We'll go to slide 23.
Okay, so now the predicted TDS, go to the right-hand column, far right column, and it says predicted TDS by rho W. Okay, now what I'm going to be doing is look at the line that is MW4S, which is also where see the red X and the blue X. Okay, so the predicted TDS is 7912. Okay, now move over to the column that's called say TDS concentration, and it's only 1400. Okay, so there's a big difference between the 1400 for the measured TDS value for MW4S and the predicted TDS. So that's going to distort the regression. Now the question is, we don't know why that is the case. If it's there's a whole bunch of other values of airborne resistivity that match pretty well, but here's a case where in MW4S it didn't match. And if I had opportunity, and I had access, I would go and I'd take a look at a lot of other MW4S values of TDS concentration and see how they match over time, if they're consistent. And so the ones that there's 2 for the MW4S, and then down at the very bottom line of the table, MW9D, the predicted was 1792 predicted TDS, whereas the TDS concentration measured was only 405. So that's about more than 4 times the amount, which is not really acceptable at all. As you look right above it, MW9M, and the predicted was 29277, and the measured was 29700. So very close together. So there's something going on with 9D and 4S. What it is, I would have to look. You'd have to look at history, other data. Is the sensor all right? Who knows what? So that's why they're cut.
Okay, and is that a normal process in statistical analysis to do that?
Yeah, in geophysics it is. You try to understand, you do the regression, and then you really start diving into your data. Why is the data showing what it's showing? You start trying to go into, okay, is it the airborne EM? Was there some noise? Go back to the AEM actual time series data. Was there noise at that location that's causing error in the estimation value? And if there isn't, then it has to be on the other end, has to be within the water measurement that data. And so that's the normal process. To try to investigate, you do the basic regression, and then you start investigating the outliers that are far away from the line and say, why are they far away from the line? What is different about these locations? And it could either be noise that you missed in your editing of the airborne data, and if it's not, then if the airborne data you say is matching the borehole geophysical log, which we saw in 4, it is. There's a previous slide further up, matches up pretty good. then the problem is not with the airborne, it has to be with the water measurement data. And then
Okay.
you'd have to go into investigation of what is that, what the source of that could be. That's why the previous slide, one of the first things I showed is you compare your airborne resistivity models to the ground control, to the geophysical logs in the area.
Okay, so then is it a similar process that you used to decide to delete the 6 data points for the EC regression calculation?
Correct, exactly.
Okay. Okay. Okay, those are all my questions about your slides. Let's go over to your testimony, exhibit MCWV4, and go to page 4. And down to line 11, 12. This is just a quick question. During your testimony, you said you got your Bachelor of Science degree in geology from University of California, Davis, and this says Berkeley, and I was just wondering which one it was.
Oh, it's Davis. You're correct. It was definitely Davis.
Okay, I figured you'd remember that.
No, that's PTSD from undergraduate.
Oh well, hopefully it's not that.
No, it isn't. No, I had a good time there, Davis. I moved back after my PhD to the area. So.
Okay, well, certainly they're both good institutions, I know. All right, let me just, I don't have a lot of other questions. Let me just flip through here. Okay, so if we can go to page 27 and look at figure 11. Maybe you can, if you can just zoom out a little bit so we can see all of figure 11. Thank you. Okay, good. So a couple of questions. First of all, I might not have read it, just may not have seen it. What are the brown curves at the top of each of these figures?
The brown curve, it's easier to see on the bottom one, on B. The brown, kind of thick brown line, that is topography.
Oh, that's the actual ground surface topography?
Yeah, and I think it says it in the legend. Scroll down a little bit. Maybe it's not in there. Okay, stop. No, you're right. It should be in the previous sections labeled, previous cross sections. It does say topography is the brown line. This one it doesn't, but that is the topography, the brown line.
Okay.
In both A and B.
Okay, and I mean, just from my simplistic review of this, I noticed that there are only 2 monitoring wells here. And is it significant to you in considering the reliability of your conclusions that basically you only have 2 monitoring wells to correlate with the data that are shown in these 2 figures?
I think that is only for illustration. I think what Ian Gottschalk was trying to show here is the thickness or the depth of the 2 gray boxes, one for MW4 and one for MW7, is to give you an idea of where the water table was indicated in those wells. So this is really just for illustration purposes. And
okay, so it's not a question of calibration or testing the accuracy.
It's a question of calibration in terms of that depth is where the water table is in MW4, MW7, and where he came up with the 75 ohm meter cutoff, how that compares to where the water level was in MW4 and MW7. But it's just for illustration, not for, I don't believe, for calibration. I think it was just a comparison. We think it's going to be 75. Let's plot it up. Now let's compare it to the MW wells where we know the water level and see how they compare. So I think it's for illustration purposes, not for anything else.
Okay. Okay, so we can go to page 37. Appreciate your patience on this.
I'm fine.
And we'll just start at the top here. This text refers to the MMGWM, which the question refers to as North Maria groundwater model. Are you familiar with this model?
Only from what I've read in his report, in this report, basically.
Okay, and are you aware that there was a 2016 version of MMGWM and that now it has been updated to a 2022 version?
Yeah, I heard last week about the 2022 version. I'm pretty sure that the 2017, 2018 report is referring to the 2016 NMGWM.
Well, it certainly would not be referring to the 2022 version, just from chronology.
Yeah. Well,
So my question is, yes, okay, excuse me. My question is, well, let me read down here at starting at line 11, the text states, the very far right of line 11, the NMGWM does not include any distinction between the upper 180-foot aquifer, the intermediate 180-foot aquitard, and the lower 180-foot aquifer. Furthermore, the NMGWM does not include the SVA south of the Salinas River, except for in a small area near the coast where it extends approximately 1 km from the Salinas River. Do you see that text?
Yes.
Okay, and so that obviously is referring to the 2016 version of the NMGWM. Is that correct?
My understanding, yes.
And do you know whether or not the 2022 version of the NMGWM makes any of these distinctions?
I have not seen the 2022 version, so I don't know.
Okay, if we can go to the next page and go down to Q42. Okay, thank you, Ms. Mullen. You can maybe zoom out one notch, make it a little easier to read. Other way. I'm sorry, make the text bigger. There we go, thank you. Great, thank you. Okay, so question 42 says, can you explain any changes in the updated model that you described in the you described as the post AEM model based on the North Marina groundwater model? So first of all, there's so many different models here. I was confused. What do you mean here? What's your understanding? What does the question mean by the updated model?
So I took this to mean that, if you recall earlier that Ian Gottschalk, he had gone through the published reports and come up with a groundwater hydrostratigraphy for the area, and then he got a hold of the North Marina groundwater model, that's in the 2016 version, and he saw that there was distinct differences between them, and so he decided to keep both models, keep the keep the NMGWM model as it was, and keep the developed published reports model. So two separate models, and those were what he called pre-AEM models. Then after he overlaid the AEM resistivity models on top of those sections and saw how he adjusted maybe thicknesses and boundaries and maybe if there were gaps or whatever, he adjusted those, and he called those the post-AEM models. So when he's talking about updated model here, he's referring to the updated pre-AEM models. In this case, it's the NMGWM model that was updated that he's referring to.
Okay, so now I'm sorry, but I'm really confused here as to who's doing what here. First of all, Mr. Gottschalk, he's making AEM models. Is that correct? He's not doing groundwater models.
He is applying. He's overlaying the airborne resistivity data, the inverted numerical data that I gave him on top of. He created. My understanding was, he created from the borehole data and published reports. He probably got locations of cross sections from different reports, and then put those into his Leapfrog program, which is his visualization program. So he located different cross sections from different reports in his leapfrog model, and then he said, okay, this is what I know, quote unquote. I have an NWGM model, and I have a published data published reports model in leapfrog, and now I'm going to apply the airborne resistivity inverted data on top of that, and then make adjustments.
What is he making adjustments to?
He'd be making adjustments. So his pre-AEM models from the published, probably called previously published cross sections, he would put those in. He may have, I never saw the version of it, but he probably could put in these different cross sections from the different published reports, and then he connected the dots between them to some degree. I'm not sure how much he did that. I'm not sure how many cross sections there were and how close they were, and if he could connect the dots. Okay, and so he had created a model, a model of the area from the published cross sections, and then a model from the NMGWM. And then what he did with the AEM data, resistivity data, was adjust the boundaries of those models. Go ahead.
Okay, so again, it's just not clear to me what model he is adjusting. What model is he adjusting?
What I would say is in the deliverable for the 2017 report, he included his leapfrog, call it session, okay? And also I think he included, if I remember right, he included like an installation program for a leapfrog viewer, okay? So what I would think is that if your staff or you, if you install the leapfrog program, the viewers, maybe an updated one since then, and then load his leapfrog session, you will likely see his pre-AEM models and his post-AEM models for both the published cross sections and the NMGWM model. Okay.
So then, what is the result? Is the result the model that's described in the 2019 report, or something else?
The result would be what he is showing in the later figures would be probably his thickness of it would be the revised boundaries of the say dune sand aquifer to the 180 foot aquifer, the upper intermediate aquitard and lower 180 foot, and to the boundary with the 400 foot aquifer, and then the SVA aquitard and the 180 400 foot aquitard. Those different thicknesses and boundaries between the different units are what were adjusted.
And did he make those adjustments because of the North Marina groundwater model, or because of something else?
He made the adjustments. He developed the North Marina ground model and the model based on the previously published cross sections. Those were call his baseline models. Okay, he had two models, and then he applied the airborne inversion results, resistivity data, and then converted, and then to that data, not converted to TDS, just the straight resistivity data. He overlaid. I think in a previous figure, it's up there. One of the figures is an example of the overlay, and that's what he did for all the different cross sections through his model. Now, one of the things in Leapfrog is you saw in that one of the first slides you mentioned earlier in my slide deck was where we had the flight lines, and the original earlier programs until Leapfrog was that you were kind of confined to your cross sections along the flight lines. What Leapfrog does for you is you can draw a line across your survey area, and it will create the model straight cross section just along that line, and it'll kind of pick up all the data from all the other flight lines. Okay, and so that's what he's done for his interpretation. I think in later down, you saw he had 4 different cross sections of results he was showing, and he was showing the adjusted boundaries of the different hydrostratigraphic layers as he interprets it based on the overlay of the AEM conversion result on top of the previously developed models from the previously published data and the NMGWM model. Does that make sense?
I think so. So then you're saying after he did all these things, then did that result in the figures that are described later on in this testimony?
Yes.
Okay. I think that's sort of clear to me.
I mean, if maybe if we go up, I'm not sure which. If you go back to the slide, the summary slide.
Okay, let's put
we
up
can look to it.
MCWD 108. Tell us what slide to go to.
Okay, let's start with like about maybe let's go up to about maybe 2 or 3. Let's have to slide through them and then find them. Or you can go up from here either too. Keep going up. This is still 2019, so let's go up. So go up to about slide 7 or 8. Okay.
Okay, we'll go to slide 7. Here we are.
Oh, okay. Now let's go up from here. So I want to see what's above this.
Okay, slide 6.
Okay, go up. And then this was that. I think that's that one. And then go up one more. Okay, now let's go down. So okay, so this is the flight lines. This is showing about the topography and the unsaturated. Go down. And then we got the borehole logs or the examples section that we talked about earlier. Go down, and here you see the brown lines, and it says in it when it says topography. Boreholes, go down, please. Go down. Down. Okay, here. So here's an example. So this is this. So this top cross. These are cross sections that we're looking in the caption. So it's cross section of post AEM model based on cross sections from previously published reports. So the top cross section is his interpreted hydrostratigraphy, his post AEM model based on previously published reports. You can see that thick red bar in the upper map, and then on the bottom is where he's overlaid the resistivity inversion results on top of the section to show how he based his interpretation, which he's showing in the top section based on the resistivity data in the bottom section. Okay, so that's the example. So then he
So
did
this is
that
an example of a transition from the 2017 work to the 2019 work?
No, this is straight 2017 work. It's showing an application of the 2017 in resistivity inversion results with the interpreted hydrostratigraphy.
Okay.
And then further down, maybe another few slides. Let's see, go down another couple of slides. Keep going. Okay, right here. This is it. Go up one.
Okay, we're at
So
slide
here on the
11.
On the upper right, you see these 4 cross-section lines. This is within Leapfrog. And so, and with this figure here is cross-section number 2, which is about, the western end is about half mile south of the CMEX area. And so again, this is his, this is showing both the model A on the bottom left is from the previously published reports, the original cross-section, and then the top.
That's the 2017 report?
2017 report, yes.
Okay.
And it's figure 19 in the 2017 report, this one. And there's a figure like, this is figure cross-section number 2, so it's going to be a figure 18 is cross-section 1, and figure 2 is 19, and figure 3, or cross-section 3 is figure 20. And so then the top upper left is from the NMGWN model originally, and the overlay of the airborne version results. And you notice on the right-hand side of the cross-sections, there's a little kind of a bracket that said this is a zone where there was no AEM data, and so there's no difference between the original pre-AEM models and the post-AEM models.
Okay, so is model B also described in the 2017 report, or is it later on?
Yeah, yes. No, it's within. So his two two models that he worked with was the NMGWM, which is model B on this, and then the model developed from cross sections from previously published reports, and that's the model A here.
Okay, so I'm going to try one more time, and then I may give up. But if you can go back to exhibit MCWD 4, page 38, and it says changes. The question again is changes in the model. So I'm trying to understand, is this changes from the models that are described in the 2017 report to the models described in the 2019 report?
This is all 2017. So in 2017, he developed two sets of models. And those two models, there was a pre-application of AEM and a post-application of AEM. And this is all within the 2017 report. And so in this question 42, he's describing what were the changes after applying the AEM to the NMGWM model pre-AEM. These are the changes that he noticed after doing so.
Okay, I think I understand. I'm going to move on.
I would put it this way: if you're going through this and it says post AEM or pre AEM, that is only in the 2017 report. Okay.
It's all post and pre AEM are both in the 2017 report.
They're only in the 2017 report. Yes.
Okay. Okay, let me just see. I think I only have a couple more questions here. Okay, you can go ahead and take that slide down or that exhibit down. Thank you, Ms. Mullen. So just in general, Dr. Ash, regarding your original written testimony, exhibit MCWD4, your answers, I didn't get all my notes down for in response to some of Mr. Osias's questions, but in general, what parts of that text, and it is 86 pages long, which parts did you write and which parts did somebody else write?
So as I think I've mentioned before, the 2017 report was developed and written by Stanford, so Ian Gottschalk and Professor Knight. Okay, and so that's probably the first half of the testimony. Okay, the questions that you see before, like question 1 or whatever, were added by Mr. Wilkins or his team. Okay, now then the second half of the report, which then starts with the 2019 study, I wrote with help from my partners and review.
Okay, now when you say you wrote it, do you mean you wrote the 2017 report and then somebody else moved that text into this written testimony, or do you mean you wrote the testimony?
Let me clarify then. So the 2017, both reports were, what do you call it? They were, the text out of both reports were put into the testimony, okay, by Mr. Wilkins' team. And then they added questions here and there, okay? Then I went through and edited it just to make it make more sense or whatever, okay? But the 2019 report I wrote with support from my partners and stuff.
Okay, I understand you wrote the report, but it sounds like Mr. Wilkins' team took the text of the report and put it into the first draft of your testimony. Is that correct?
That's correct. Mr. Wilkins took both 2017 report and 2019 reports and put them into this testimony format.
Okay, so about how much time did you spend preparing your original testimony, exhibit MCWD4? How much time did you actually work on that?
Quite a bit, actually, to review. A lot of it was just making sure that everything there's no typos, except for the big typos that Mr. Osias found, which I thank him for. But really to look for typos, if the questions made sense, we're referring to what was in the text. If what was in the text was responding to the questions that were listed, things like that. My part was also on advising like which figures out of the reports should go into the testimony, which because there are a lot of figures, there's like over 100 figures in the 2019 report. I mean, you don't want to put all these into the testimony. So we tried to go through and try to add figures that would kind of summarize or illustrate different features of the reports.
Okay, can you
Okay,
put
so
any
that-
handle
so-
on any estimate for number of hours you
hours?
work?
Yeah, I'd say probably about 27, 28 hours, I'd say.
Okay,
Because originally there was going to be a deposition, a few weeks ago or something. So I prepared for that, and that's where all this testimony was coming from way back when. And then there was some rebuttal. I received some rebuttal questions from Mr. Wilkins. So in the end, it was about 28 hours or so.
okay. And while you're talking about rebuttal, your exhibit MCWD 91, please just tell me how you prepared that. I understand you got questions from Mr. Wilkins. Did you prepare the answers that are in that testimony?
I did. Mr. Wilkins asked me to take a look at some of Mr. Lepler's appendices, if I recall. I think Appendix B and C. I don't remember. I don't remember exactly. But he said, take a look at these pages and this thing, and please comment if you have comments. And so I did that, and then I returned it back to Mr. Wilkins. And
So you prepared
I think
at least the first drafts of the answers to his questions.
that's correct. And I think he added the questions.
Okay. Okay. What I'm going to do, well, first of all, let's just go through here. Mr. Wilkins, you can go off mute. Do you have any redirect questions for Dr. Ash?
Some short questions, yes.
Go ahead.
Are we at a breaking time where I could check in with him to see if he has anything else he would like me to help him clarify? Or if not, I can ask my questions and then maybe we'll take a break. I just want to make sure.
Let's go ahead and do that. And, of course, you can talk with him, but then, of course, Mr. Osias can ask you about what you talked with him about. You know the drill. But that will give me a chance to ask my staff if they have any follow-up questions. They certainly understand these technical details a lot better than I do. So let's take a break.
I can ask my direct questions, and then he may not have anything he wants me to clarify. I just want to make sure that if he has something he feels didn't come out that correctly in his testimony, that I get a chance to ask him about it.
Yeah, and that's fine. I don't have a problem with that. But anyway, as I said, just warning you, if you talk with him, Mr. Osias can ask you what you talked about.
Absolutely.
Oops, and I'm sorry, my screen, I move it to look at the details of some of the exhibits, and then I don't move it back so my camera's right. I apologize. Okay, so let's take 10 minutes. I will also ask my staff if they have any questions, and we'll reconvene at 10:25. And just a reminder, turn off, if you want to, if you don't want people to hear your discussion during the break, turn off your microphone and camera, but don't log off, and we'll come back at 10:25. Thank you. Okay, sorry, I apologize for the delay. As I mentioned, I was talking to my technical staff. And it just took a few more minutes than I anticipated. So, Mr. Wilkins, before we get to you, let me just follow up one more time with Dr. Ash. If Ms. Mullen, if you can display exhibit MCWD4 and go back to page 38. Okay, so Dr. Ash, I've asked you some questions before about the changes that are described here, which you testified that Mr. Gottschalk made based on the North Marina groundwater model. Do you recall those questions a few minutes ago?
Yes.
Okay, so I think the question my staff is asking was, did Mr. Gottschalk make changes using Leapfrog to the solids model of the basically of the area?
The solids model?
Let me back up. Are you familiar with the term solids model?
No.
Okay. Well, so let me try it a different way then. Did Mr. Gottschalk essentially change the lithology in his model based on this new information from the North Marina groundwater model?
I don't think he changed lithology. He changed hydrostratigraphic boundaries. So
I'm sorry, hydrostratigraphic what?
He may have thickened the upper 180 aquifer and thinned out the 180 aquitard, maybe thinned out the 400, things like that is what he would have done. He would not have changed lithologies were already predetermined by the published reports. This is the lithology of the upper 180 and things like that. No, what he was just changing was where the boundaries were between the different stratigraphic units.
Got it. And that would be the vertical boundaries?
Well, I mean, I would call them
the vertical elevations of the boundaries, I should say.
Yeah. It's called vertical elevations, yes.
Okay. Sorry, I'm writing this down. So did he make any changes to the mod flow simulation?
I don't have the impression he ever was exposed or even knows about the mod flow simulation.
Okay. So do you know
what happens with this kind of data is we do our analysis of it. We do the inversion, acquire the data, invert it, do the basic what we think is an appropriate interpretation or modification to whatever, and then we provide a file to the groundwater modelers, and then they do what they do with the model, with the data.
Okay, so if there are changes in hydraulic conductivity of a particular aquifer, would those be done then through the changes in the mod flow modeling process, as opposed to changes in the boundaries of the different formations?
Yes. Yeah, we would not. Geophysics people would not be adjusting hydraulic conductivity.
Okay.
We would leave that to the hydrologists and the groundwater modelers. Okay.
All right. Thank you. That answers my questions for now. Okay. So, Mr. Wilkins, you may go ahead with your redirect.
Thank you. Good morning, Dr. Ash.
Morning.
You testified that you didn't write the 2017 report that we've been discussing, or you've been discussing. Can you clarify your involvement with the 2017 report?
The 2017. Your question is, this clarification is the 2017 Stanford report, correct?
Yes.
Okay. So my involvement was let me just kind of summarize our involvement in the project. Our involvement in the project was, our job was to acquire the data, apply QC, invert the data, and provide that information to Stanford. And then Stanford's role was to take that data and then do an analysis and a transform from resistivity to lithology and or water quality. Okay,
And-
so in terms of the actual report, my job, they provided us with a draft of the report. We reviewed it, really checking for, just kind of grammar and typos, and if figures were okay. Like Mr. Osias noted this morning that the primes were missing on a couple of those cross sections, which I hadn't noticed before. But that would be the kind of thing we would have been looking at to have Ian correct before publishing it, delivering it.
And so did you have conversations with anyone at Stanford about the report before it was published?
We turned in our draft review. We would, here's our track changes review of the report, and they would say thank you, and that was about it.
And do you know Dr. Knight, who was one of the other authors of the report?
Yes, I've worked with Dr. Knight for several years on other projects. This project and other projects.
Do you have an opinion on her qualifications in the field of geophysics?
She's very well qualified. Her prime area.
Objection. I'm sorry. This goes beyond the scope of Cross.
Um,
I believe I asked a single question about Dr. Knight.
I'm going to overrule the objection. I think this goes to the general context of the report. Go ahead.
Dr. Knight, her main area is rock physics. So, understanding the actual small details of lithologies, different lithologies and how they relate to each other. She's very well respected in the geophysical field. I believe that she just got an award from the Society of Exploration Geophysics this year for like distinguished lecturer, distinguished professor or something. So she's very well respected.
In your opinion, would Dr. Knight allow a paper to be published with her name on it without reviewing and agreeing with the opinions?
She would not.
And do you agree with the opinions and conclusions reached in the 2017 report?
Yes, I would say yes.
Is your 2019 report consistent with the opinions and conclusions in the 2017 report?
I would say yes.
And unlike the 2017 report, did you do all the geophysical interpretations and calculations for the 2019 report?
Yes.
And you were asked questions about pre and post AEM models for the 2017 report this morning. Can you describe what you did for the 2019 report relating to that? And maybe Mr. Lilly now understands that it wasn't mod flow. I guess I'm just trying to make sure it's clear for the record what that difference is between the pre-AEM and the post-AEM model when you're talking about that in the world of these AEM reports.
Okay, so why don't you rephrase that as a short, succinct question, please?
Sorry, I'll strike it. Can you describe what you did in terms of pre and post AEM models for the 2019 report?
I didn't follow that. I didn't follow that path in
Okay.
2019.
So what did you do in 2019 differently?
I did what we usually do, which is you take the inversion results and you have them as, they're along the flat lines, or if you use Leapfrog, you can make your own cross sections. And then you take the data and then you start comparing it to first the borehole physical data and then to the borehole lithology logs. And then you start working on correlation regressions between the resistivities and in this case, TDS. And then you prepare, you develop a relationship, and then you apply that to all the data. And so I didn't have a pre-AEM. I just went with the data we had and I knew that within the data from the 2017 that there were these different hydrostratigraphic units, and I just accepted those. That's the area. Okay, fine. And now I have a new set of data, and let's just see how it compares with the 2017 data.
And yesterday you testified that your testimony and report used the term chloride concentrations when you meant to use TDS. Does that change affect the substance of your testimony regarding the distribution of groundwater within various TDS levels in the study area?
No, not at all. I just I've been working the last 6 years with chloride concentrations only, and I just think as chloride as representative of that group, and I should have changed it to the actual TDS because there is a difference between them, and I should have been more accurate in the report and in the direct testimony. So I apologize for that.
And can you explain briefly what that difference is between chloride concentrations and TDS?
My understanding is that base chloride is as a subset of what goes into the TDS. There are other, I'll call them salts, other components, elements that go in to make up a TDS, total dissolved solids.
And did we talk during the break?
We did for about a minute.
And what did I ask you?
You asked if I wanted you to ask me about anything, and I told you no.
And did I ask you any other
Nothing.
questions?
No.
And you said how long did the call go?
About a minute, a little over a minute.
That's all I have.
All right. Mr. Osias, I really don't think you need to do redirect on that, but is there something you really want to do a redirect on based on the what we've just heard from Mr. Wilkins' questioning?
Mr. Lilly, I think you mean recross. Is that fair?
That's what I mean.
Thank you.
Thank you.
Um,
I'm
well-
going to give you a chance, but only if you really need to.
Well, I was just going to ask for the names of the people who did the hydrogeology and lithology modeling at Stanford, if he knew, that was applying his data rather than just the generic. But if you don't think that matters, I'll move on.
No, go. You can ask that question. Go ahead. Turn it into a question.
Okay.
Sorry.
So because sometimes you like to know where I'm headed. So that
Thank you. Thank you.
So, Dr. Ash, you remember your comments of just a few minutes ago about what happened with and your involvement with the 2017 report. And at least my note taking suggests that you turned over the data you acquired after converting it to AC or whatever the right term is. And then the Stanford team applied it to lithology and hydrogeology. You said something to that effect, correct?
Yeah, I think.
And was Mr. Gottschalk involved in that application of hydrology and lithology, et cetera?
I think he was involved in looking at the airborne resistivity results and then comparing it to the previously published cross sections and then the NMGWN models, if that's what you're asking.
Okay. And do you know if Hopkins Groundwater Consultants was involved in that effort?
I don't know. I don't know. I read from Mr. Leffler's testimony that Mr. Leffler talked to Ian after the August presentation, and that Ian had mentioned Curtis Hopkins. And then I read in Rosemary Knight's letter, which is MC 39, there's a paragraph that describes Mr. Hopkins' involvement. And it looks like Mr. Hopkins directed Ian towards different reports and studies that he should look at when he starts comparing the resistivity results to stratigraphy.
Okay. And he was a consultant to the MCWD, correct?
I don't know. I don't know what his exact role.
Okay. Thank you, Mr. Lilly.
Okay. So we are now done with MCWD's first round of witnesses, which was Mr. Schertzinger and Dr. Ash. And Mr. Wilkins, I was trying to finish up yesterday because we're already after 5 o'clock. I should have asked you to prepare a list of the exhibits, the MCWD exhibits you want to offer into evidence now. Do you have that list? If you do, you can offer it now. Otherwise, we can come back and do that first thing on Thursday morning.
Mr. Lilly, before he does so, may I be heard on an issue?
Okay, if I have to go to my different gallery so I can find you here. Just a minute. Who is speaking?
This is Michael Betts for.
Okay, go ahead, Mr. Betts.
Thank you. We would respectfully move to strike all of Dr. Ash's testimony, his direct, his rebuttal, and his live testimony. And the grounds are, as you may imagine, he started out yesterday taking the oath under penalty of perjury to say that all of his direct testimony as written was his testimony. And as we've learned since then, it wasn't. It was significantly written by lawyers. Certain excerpts were taken from other experts, and a large portion was written and or authorized by Mr. Gottschalk. And in that regard, we don't even know exactly what he did, what edits he made, and beyond edits. We think edits are fine. We get that the attorneys edit, but this was so significantly written by other people, contrary to what I think you ordered early on. And it's so riddled with mistakes, fundamental fatal errors. For example, and this is not inclusive, the TDS versus chloride. Certain the charts that you asked about this morning don't add up. Obviously, the school was wrong. That's not a one in and of itself. There is testimony in there about hydrological issues for which he does not have the background, admittedly. Indeed, the city of Marina, in their very short questioning of him, asked about one sentence in his report, his direct testimony, which even he had to concede was not based on his personal knowledge. So if you look at the cumulative errors, the fact that it wasn't written by him, but the attorneys and other people, I think up to page 50, you have an admission it wasn't his work, that it violates all the canons of reliability set forth by the Supreme Court in Sanchez, the most recent case also in Sargon. And I understand that we're proceeding pursuant to the government code. I've read that code several times, as well as cases that interpret it. But this is so infected that it doesn't seem to be useful, and therefore we respectfully move to strike all of his testimony.
Okay. The motion is denied. I will say I am disturbed by the process that was used to prepare Dr. Ash's testimony. I tend to agree with you, Mr. Betts, that it's not the way I certainly envisioned the testimony would be prepared. I mean, I envisioned certainly Mr. Wilkins sending Dr. Ash questions was appropriate, but I certainly envisioned that he then would write out the answers. And of course, there can be editing back and forth. That's the way it works, and that's fine. But this seemed to be a lot more just attorneys writing things and then Dr. Ash reviewing them and just, editing it and then approving it, particularly regarding the 2017 report text. And frankly, I found it hard to follow in places when it talks about we did this and the report does this, and it's not clear as to who we is, what the report is, and so forth. So I am disturbed by that, but I think at the end of the day, your objection goes to the weight that I should give the testimony, and certainly you and your colleagues may raise those issues in your briefing on this, but I think the objection goes to the weight of the evidence rather than to its admissibility. I'm not seeing anything that any specific rule of evidence that would bar the exhibits from coming into evidence. So the objection is overruled, but my concerns are noted for the record as well. So with that, Mr. Wilkins, do you want to offer any MCWD exhibits at this time, or do you want to wait to compile an organized list and do that Thursday morning?
I would like to wait and compile an organized list.
Okay, I maybe it was too fast anyway. So here's what I would like all parties to do. I'll go to Ms. Muzine first, since her electronic hand is up, and then I'll circle back. Go ahead, Ms. Muzine.
Thank you, Mr. Lilly. Just briefly, would you like for us to move Mr. Scherzinger's exhibits into evidence today, or should we wait and include those with Mr. Wilkins' list for Dr. Ash?
Yeah, I think it's best to just wait and do it all at once. Your assignment for some or all of the MCWD attorneys is to prepare a list of the MCWD exhibits that you want to offer into evidence during this phase of the hearing, which presumably will cover those from Mr. Scherzinger and Dr. Ash. And think that's it. And of course, the ones for Dr. Kincaid and Ms. Nelson will wait. So that's why it's a little confusing as to which ones are which, and it's probably easiest to write it all out. The other parties, City of Marina and CalAm did use some exhibits during cross-examination. So please follow the normal process I've asked for. If you asked for questions about excerpts from deposition transcripts, I think there may have been some of those with Mr. Schwartzinger, I'm not positive, then please prepare an exhibit and give it next number in your numbering sequence of the cover page and the pages of the transcript that were read. And CalAm also has previously offered some exhibits. I believe it's 90 through 102, but I'm not positive I have that right. And I think yesterday the CalAm attorneys were going to confer with the MCWD attorneys regarding whether they could stipulate to the authenticity of those exhibits, which seems like something the parties should be able to stipulate to. And then I will rule on the admissibility of those, assuming CalAm wants to reoffer those. I told CalAm they could reoffer them after Mr. Schwartzinger and Dr. Ash had testified. So I will give CalAm an opportunity to do that on Thursday, and we'll rule on those as well. So basically, excuse me, by the end of the day, 5 p.m. on Wednesday, that would be tomorrow, November 2nd. This is for the attorneys who are not on the site visit. Please send the AHO an email with CCs to everyone on the service list, listing the exhibits that your party wants to offer into evidence. And then we will discuss those exhibits and objections to them Thursday morning and go from there. Obviously, one email per party. So 3 emails total. And we'll go forward on Thursday. And then we will proceed with Mr. Long as City of Marina's sole witness for Thursday after we cover those exhibits. I think that takes care of that. Just one reminder, Mr. Neudecker said it before, and I want to repeat it. As I've said before, I take safety considerations very seriously. And Mr. Neudecker raised some. No shorts, no flip-flops, closed-toed shoes, long pants. Mr. Neudecker is going to provide, or his client is going to provide, up to 15 hard hats and vests. We will meet at the City of Marina parking lot, which was in City of Marina's proposal for a site visit. I'm going to try to get out a site visit itinerary this morning before I leave. But the target will be to meet Thursday morning at 9 a.m. For that. And we will, I think, Mr. Neudecker, it's probably best to just do the safety briefing there. I want to make sure we do it somewhere where we don't have a lot of traffic going by.
I think you mean Wednesday at 9 a.m.
Boy, I'm not doing very well today. Thank you. I meet tomorrow, Wednesday at 9 a.m. Yes.
And I can check, but I think the CEMEX folks are planning and might need to do the safety check at CEMEX, because okay. I think there's some forms people need to fill out. So I don't think it's something, I could be wrong, but I don't think it's something they can do on mobily.
Okay, well, that's fine. Excuse me, I don't want to interrupt, but I'm going to. As long as there's a place where we can all park out of traffic, that's my concern.
I'll double check, but I think, meeting at City Hall, if that's to start, it seems fine to me, but I can check with the CEMEX folks and make sure there's parking.
Yeah, we'll meet at the City Hall at 9 a.m. for sure. We will then either do the CEMEX briefing there, or if your client, the CEMEX people, want to do that briefing on site at CEMEX, that's fine as well. As long as we can go through the gate and park somewhere. My only concern is I don't want to do it by the side of the road where cars are driving by, just for safety reasons. If that makes sense.
That's not my understanding of how or where it will be done, but I'll double check.
Yeah, okay. That's good. So I think we're getting there. And of course, Mr. Long will be ready to go Thursday morning after we cover the exhibit admissibility issues. So is there anything else for today that we need to cover? Mr. Wilkins, your hand is up. Go ahead.
You asked me to check on whether we would stipulate to the authenticity of the MCWD and so as long as there are Bates numbered versions of those documents that we have produced, but assuming they want to use the versions that they have downloaded that don't have those Bates numbers, we would stipulate if they will make a representation to the record that they were downloaded from the MCWD site and not modified. We're not going to go online and check each of them, but assuming that's the case, we don't dispute their authenticity, I guess is the point.
I hope we're not to the point where any of the attorneys in this proceeding would fabricate exhibits. But Mr. Moore, do you want to stipulate to that now, or do you want to wait till Thursday morning to stipulate to that?
I can wait till Thursday morning. It's fine. I have one other question, but if you
Go ahead.
recall, we kept Mr. Scherzinger around because there were other documents that made it authenticated. And we've got 4 or 5 right now. And I'd rather not have Mr. Scherzinger come back on Thursday just to authenticate these documents. They are documents of.
Wait. Mr. Scherzinger, can you come back Thursday? It's going to be a lot easier to do this when we can just go down the list of Cal-Amex.
That's fine. Yeah.
Can you participate Thursday morning?
Yes, sir.
All right, let's do it that way, Mr. Moore. I appreciate you're trying to be efficient, but it'll be easier to go down the list. If there's agreement, he doesn't need to authenticate. If there's not agreement, we can ask him to authenticate.
That's fine.
So we'll do it that way. Again, I seriously doubt that authenticity is an issue with any of these documents, but if it is, we can address it. Okay, so anything else for today? I don't see any other hands up. So that sounds good. We will wrap up. Mr. Long, you can get ready for, I'm trying to remember, I think you have the city council meeting coming up. And Mr. Spalding said you wanted to finish by 11 a.m. tomorrow, so we will just make it.
Thank you. We do have a city council meeting tonight.
Okay, and that'll be fine. Then we won't interfere with that. So, okay, so for Mr. Scherzinger and Dr. Ash, thank you very much for your attention and time testifying yesterday and today. I appreciate your careful listening to the questions and your careful answers. Thank you to all the attorneys, as always, for behaving professionally. It sort of makes my life a lot easier. And with that, I will see those of you who will be on the site visit tomorrow morning at 9 a.m. at the City of Marina City Hall. And for everybody who's participating electronically, I will see you all Thursday morning at 9 o'clock back on Zoom. So with that, everybody have a good day. Thank you.